Again, double click, I search for surface, right click, and then search one surface, then I click on the surface in Rhino. Then I hide it in Rhino. Afterwards, I want to talk about MeshPlus Plugin. And this plugin is a simple plugin and also functional, helpful. You'll find it lovely. Firstly, we should give a mesh to this. But here we got a nerve surface. We double click, then we type mesh surface. Watch this. Here, firstly, we should give the surface to mesh surface, and then it converts it to a mesh. Watch this. And then I wanna propagate or array a module on each of these panels or a 3D object. For instance, 20 and 20 for the UNV counts, and as much as we increase the number of the UNV counts, the file size will increase too. We can begin with 12 and 12, and when it was okay, we can increase the UNV counts. Okay, since this process is parametric, and when the definition was finished or done, we can increase in the UNV counts. Here from subdivide, watch this, x plus 2. We add this. However, some of the plugins do not work in Rhino 8. Anyway, like frame plus O, or I can choose one of the subdividers, okay? The subdividers subdivide each of the panels or divide each of the panels. We give the mesh to the geometry at first, then we got other inputs. Let me add some of the subdividers to show you the inputs. G is related to the mesh or geometry. T, we might have multiple T inputs, T1, 2, 3, and 4. The T inputs require a value between 0 to 1. For instance, 0.234. Watch this. And when we change it, look, we're changing the thicknesses of the frames. I hide this, I make a copy out of the number slider. I specify the thickness. And then for the another one, look. And we got the D input as well, which requires a value for depth. Look, watch this. As you can see, we are opening the panels like this way again. I choose, let me see. I want to work on the 3D options in volume, in Vive. We got some options for Vive and some other options for the volume, for the solid objects. For instance, if I want to use Vive, I give the mesh, and this will be the result, like this way. For T, I should specify a value between 0 and 1, like this way. Check this out. And then for D, or depth, actually the distance, check this out, between the two parts. I prefer to use other tools except Viv. Let me search for mesh join to join the meshes, like this way. And then, in order to make sure that the vertices are meeting each other, we add weld mesh. Afterwards, I want to use the Catmull-Clark algorithm. Catmull-Clark subdivision to make them smooth. I specify 3 for the level of the Catmull-Clark subdivision, and mesh. Let me search for thickness, thicken actually, for thickening the mesh, 0.25 for the distance. As you can see, we got the solid objects. I increase the distance. Well done. I bake this object, and then we get back to Rhino. And in order to work on it more, check this out. I have associated the polished material, and as you can see, we are not able to model such a texture or such a model in Rhino. It is very complex. As you are concerned, it takes too much time, while we can use the MeshPlus, Viverbird, Catmull-Clark, or other options and create this in just a few moments, as I showed you. So, up to now, we learned to work with these plugins in Grasshopper. Well done. I close this, and in the continuation, I had the definition, and as we talked about the MeshPlus and also subdivision, MeshPlus and Viverbird, we should associate or link G to mesh, and for the T inputs we should specify a value between 0 and 1, and for D we specify the depth of the geometry or the surface. We covered MeshPlus and Lunchbox, and we got another one named Viverbird, as you can see, which used in creating panels. Let me show the mesh here, mesh surface, like this way. I select them, watch this, and I want to use picture frame or window to convert the mesh. Look, picture frame or mesh window. We specify the distances for both. Then we modify the number sliders. Okay. Look, for creating the windows or picture frames. However, I can do this in whatever meshes and also inset them. Let's type the Catmull-Clark subdivision for smoothing the meshes, or using mesh thicken for extruding the surface, or volumize it. Let's see. The next one is Parakeet, as you can see, which is a collection of components focusing on algorithmic pattern generations. Let's move on and show you the Parakeet slides. Watch this. In Parakeet plugin, we got some tools that they create geometric patterns for us. For instance, tiling or base grid, that we use it with or in conjunction with pattern generation method, and then we'll have the pattern as a result. Anyway, let's give it a shot in Parakeet. Firstly, we got tiling, which is the base grid, and also the pattern generations. Anyway, let's see within multiple examples. we add the truncated hexagonal for the base grid, we can control its size using a double click and defining a number slider. Watch this. And also the number of the hexagonals extend in uh, X and Y directions, as you can see. This is its simple structure. We can bake it or we can work on it more. I specify 2 for size, 12 in 8 for the extent X and Y. Anyway, after adding the tiling or the base grid, it's time to create the pattern generation. In this part, we give the grid cells to base grid, like this way. And then, as you can see, we got different items for pattern genotype and pattern genotype N, as you can see, and the value that we specify for factor must be a value between 0 to 1. Watch this. So we control the whole pattern, defining some parameters. I zoom in between 0 and 1 for the parameter. I set it to, or I link it to parameter B. Look, we can see the changes in webs. And then for star size between 0 and 1, like this way. Well done. And then the degree that we can specify the same. After using tiling for the base and then adding the pattern generation, we can have the pattern done. And we can have different kinds of results like Morris Escher tiling that enables us to create some patterns of Morris Escher. Let me search for the patterns to show you. Watch this. I want to show you the works of Morris Escher. Look, as you can see, we got these patterns beginning from a fish and converting to birds, for instance, or other things. Watch this, that we can give some curves and lines and then they will be morphed. All in all, we got too many tools and plugins in Grasshopper that we don't have enough time to cover all of them. Let me search for the plugin of Pufferfish, as you can see. Let me search for it. Pufferfish. Here it is one of the few animals. And then let me show you some of the results that you can model using this plugin. Watch this. No, we just give it to surfaces and then it creates these. Look, that we can download the examples of these plugins as well, that we can check the examples and learn how does it work. And after checking the examples, we can try the same pattern on other examples or cases. Up to this point, we talked about the creating patterns in Grasshopper and Rhino. But all in all, I just wanted to tell that Grasshopper enables us to create patterns as fast as possible comparing to other softwares. And also, even those who are working with Revit, we can simulate the Grasshopper to somehow dynamo in Revit, which is a visual programming software, but you should note that Grasshopper is very powerful than Dynamo in the field of modeling actually. More powerful and also more functional, and with having too many plugins and tools that it doesn't let you alone in your challenges and model whatever you want. And here there are some great matches between the base grids and also the patterns that, like Gilbert tessellation, that you can have a great match as a result if you use these base grids and patterns with each other. And also these venation, as you can see, type 1 and type 2. Let's check them out. And other algorithms of growth, as you can see, that you can get access to them in Parakeet plugin, that I can share these files with you as well.